Who likes my Twitter handle? Is that a cool Twitter? See? It's a cool Twitter handle.
Yeah, afterwards you get to guess what it means, right?
It doesn't mean anything.
Or does it?
No.
It's a part of the CTF.
This is not the Illuminati. No.
Yeah.
All right, so we're going to get going.
Yeah.
So today we're going to talk about the economics of incidents and what that means. To be very clear, neither Frans or myself are economists. This is a hacker in his natural habitat. Everybody say hi.
Hi.
I'm an incident responder, so I'm the guy that actually generally will defend Frans. Frans is legal. He actually does it as a red team and as HackerOne.
Yeah, I should say that it's like not the bad person here, and I hopefully I should be here without getting caught today. No, so I work as a security advisor on a company called Detectify, and I'm also doing a lot of bug bounties. I was like Obelix, I think it's called. Like I was born in the bug bounty industry, coming into security. So that's how I became like a white hat. So yeah, that's
cool.
Yeah.
Today we're going to try to cover some basics. We're going to go over the introductions, obviously. We're just doing that now. We're going to look at some of the threat landscape and try to talk to you about how the threat landscape has changed over the past couple of years and what's changing, what's changing now and what we need to be aware of. We're going to go into awareness, things that are actually things that you need to think about today and the way that you defend your architectures and the things that you have out there now. And then we're going to go into the future and make some, I'm going to call them bets, I suppose.
Yeah, and advices.
Yeah, advice. Hope you enjoy it.
Yeah, and like we wanted to talk about real things. We wanted to take some examples into consideration. We wanted to like tear off the bandage kind of way. And we also wanted to focus on the actual impact of incidents. There's a lot of numbers out there, but we wanted to actually get down to the business. What does it mean getting an incident? What is the actual economics around it? Yeah,
and one of the things that I see as an incident responder is that when companies or enterprises out there have an incident, nobody wants to talk about it. It's very hush-hush, we're all quiet about it. Everybody closes up, and one of the things that we'd like everybody to do is actually talk about it. I think it's really helpful when different companies talk about the experiences that they've had locally to other companies they trust, so that those companies can then learn from your mistakes, and to be fair, you can learn from theirs. Ideally, you all go forward together as opposed to a bunch of individual companies trying to defend each other, or yourselves, frankly. So one of the things we'll talk about at the end.
And also, we will focus on some tech, but we, in the end, will always realize humans is a big problem of all of these things. Spoiler alert.
Yeah. Yeah. So, why are we doing this call, this talk?
I mean, in the beginning when we started discussing doing this talk together, we kind of wanted to find like a debate behind us or like between us. He's coming from the provider. I'm coming from the attacking kind of way from it. I'm the one creating incidents. He's the one like taking care of them. But when we started talking and discussing, we kind of realized that we want the same things. We think that the same kind of things are actually wrong and needs to get better. And we also had like similar ideas around how to actually change that.
I think that was the biggest surprise for me was as we started looking at it, I've actually in my previous careers been a hacker or a red teamer myself. And so working with Frans and going back and forth about that, we found that realistically when we look at the way that the world's moving, I think a lot of the issues can be solved with some tech, but a lot of the issues are human-based. And we start looking at different changes to internal company process and procedure that maybe you haven't looked at before. We're going to talk about some of that. All right, so some basics. This is kind of, yes, this is the part of the talk that is eat your vegetables. Sorry if you guys have already done this before, but we're going to go through it. Who understands the shared responsibility model? Oh, thank God. This is a good thing. We appreciate this. The statement of I'm going to move it into the cloud and it's going to be secure, period, is a great statement to make. We are more secure in the cloud, and Frans and I will debate that a smidge later. But one of the things that we need to make sure we tell you about is that when you get something in the cloud, that responsibility is yours. Your cloud, your stuff in the cloud is your responsibility. I will help you as an incident responder as much as I can. I will help you as an SA as much as I can. I will tell you things that you can do. But in the end, your stuff is your responsibility. Protecting the cloud as a whole, all of AWS, is my responsibility. That is AWS's responsibility, and that's the part that we will focus on. Does that make sense to everybody? We all good? Okay. And this is one of the reasons we're good at protecting your stuff, right? We look at this, and I really want you to take away from this, this is a lot more than just a data center in IAD, Washington, And that's what an AZ is. It's not. An AZ is actually a collection of data centers or pieces of data centers. So when we talk about DR, when we talk about uptime, we're not talking about a region from the point of view of just a couple of data centers or a data center. It's a much larger thing. So I want you to kind of think about that as we go through some of these architectures, and frankly, as you do your architecture in the future.
And also, the problem is if you have a bad application, badly written application, bad processes in place, cloud will not make that magically better. It will be a bad
No?
practice. I would say no.
No, okay, no.
Yeah.
So bad practice is bad practice. We can't fix bad practice. It doesn't matter how good your application is. If you've got bad internal practice, you're going to have problems. And regardless of how you architect, regardless of the cloud you're using, regardless of anything that's going on, you're going to start having issues. So let us try to understand what some of those best practices are. So segmentation, one of the primary things that we look at in the messaging that we send to you. We talk about multi-account, we talk about segmenting different things, but one of the things that we don't often talk about is the way that we segment our data. And who here is government? Anybody government? So data classification means a lot to you, right? Data classification, if I can ever get it out once, is a lot of fun, but the reality is that what we end up seeing is that if everything is bold, then nothing is special. So it's really easy to classify data as really important, secret, top secret, and all of a sudden then this huge thing is top secret, we don't know what to do with it. Or this whole architecture is PCI compliant or HIPAA compliant, and does the entire architecture need to be? So we end up with needing to learn about segmentation again, not from the multi-account strategy, but from our applications and how to segment those applications.
And there's some good examples of segmentation. I've seen like one app had every authentication model in their whole microservice architecture was based around one application. That application did the same thing to authenticate all microservices. That means that you couldn't launch a microservice without use that authentication app. The problem is though, like as an attacker, I would focus on that app, because that means if I can break that one in any way, that's like a single point of failure, basically. If that one is broken, everything is broken. But it's a good segmentation.
Yep. And as we get into this, I mean, so Frans and I will debate a little bit about the cloud is safer. When we started, that's not actually what you wanted to say, is it?
No, so when we wrote this slide, I was like, okay, should I say this as an attacker? Because most of the time, I attack cloud services, and I attack applications running in the cloud. And when I started thinking about it, I realized like one of the reasons why that is that I know how the cloud works. And I also know how to identify if a company doesn't know how the cloud works. So it's all about the knowledge that I have around the cloud that makes me actually target it much easier. I know how S3 works. I know how EC2 provisioning works and CloudFormation. I know exactly what you can do wrong, so I will test for those things. So I would say it's safer because it's like the documentation is out there. There's no security by obscurity.
Yeah.
And it's much easier also for legit people doing a good thing, actually identifying those issues.
Well, and historically, when I was a hacker, one of the ways we would attack a data center is doing something simple like USBs in the parking lot. And we'll talk about that a little bit later too. But you start looking at the cloud versus a data center, cloud versus anything else. And really for me, it's the eliminating the human interaction and being able to get down to the logs and the things that actually happen in the cloud. CloudTrail is your friend. Everything that happens in AWS APIs will go into CloudTrail. Because that's true, I can defend against Frans really easily. I can say, okay, the reality is I've set up my shield, and I can start watching my guard duty shield, see how I did that? And go ahead and look at all the things that go on from Frans.
Yeah. And the same, like I've reported issues to people because they leaked their AWS keys. Yeah. And suddenly they go back to me and like, can you stop testing those keys? Like our alerting monitoring is just screaming all over the place because we have that monitoring in place.
And then we get into kind of this weird thing. This is where both of us are going to start going into some of our history and stories that we have, which are kind of fun. But as we talk about segmentation and we talk about application segmentation, I want you to start thinking about some realities. I got to sit with a customer that had a lunch application, effectively. And this lunch application kind of worked like this. Frans would go ahead and decide that he wanted a hamburger for lunch. And so he would go to the website and enter the fact that he wanted a hamburger. And the website would look at his SSO and go, hey, that's Frans. Frans, would you like a hamburger?
Yeah.
Okay, cool. Here's your SSN and here's your hamburger. Oops. So if I'm the developer and I'm writing the stuff, why did I do that? I did that because Frans's name is in a data set right over there, and that's just easy, man. I can get his SSO, I can grab his name, I can put it all on a table and we're good. Downside is if we haven't thought about segmentation and data privacy to begin with, privacy by design, then all of a sudden Franz's stuff gets leaked into the grilling app, the lunch app, and whoosh, all of it goes out to the internet because somebody hacked the lunch app because nobody cares about the lunch app and nobody's really paying attention.
There's some other like nightmare scenarios of, I heard one company, there was a live hacking event. We went out a bunch of hackers hacking a company, and one of the hackers wasn't looking at applications. He was looking at YouTube videos of developers putting out, like, this is how you build with this application. And in one of these YouTube videos, one of the developers had an API key. It was like, he showed, like, this is how you talk with the API. Turns out that that API key worked and was also an admin. So suddenly you have, like, you need to cover your social media and your documentations and like YouTube videos around developers showing how you use the app as also a potential way to leak data.
Data is really interesting when you start looking at all of this. And that kind of brings us to the next topic here. What do you want to protect? So this is kind of one of those basics. As we look at this, and I look at this as a hacker, and you look at this as a hacker.
Absolutely. Yeah. We're doing this by ourselves. When we approach a company, we think, what can we actually gain from accessing this company? How can we explain how bad the vulnerabilities we find is by explaining what kind of data we can actually extract or use or abuse?
Yeah, and it starts to get really interesting when we start to think about the grilling app, for instance, right? That company had specific things that were personal data that maybe we wanted to get that, maybe we just wanted the PII for that, depending, great. But now all of a sudden I know about a specific company's employees. How can I then go ahead and fold that into other attacks that I've made in the last 6 months? And so what we're seeing is not necessarily just this concept of, hey, I've stolen your information. I've stolen a piece of your information that maybe I'm then going to go ahead and tie over to your social media profile and then look at a couple of other things in tandem and come up with some really interesting information sets. And so it becomes marginally hard for us to tell you all of it's important. Well, that's not a great answer. We can't tell you that, right? We have to start segmenting the data and dealing with the privacy by design to begin with so that your lunch app doesn't have your social security number in it. Does that make sense? We all good? All right.
And this is a classic.
This is your favorite slide, I think.
This is my favorite slide. I'm also a security vendor, so I'm like, look at this. Look at how bad the world is. Like, everything is broken. This is so bad. We're just getting worse. But this is not the truth, right?
Who gets like agita? Who gets stomach cramps when they see slides like this?
Like, we're gonna talk about how bad the world is.
Right?
No, so when we see this, we see that, okay, this looks really bad, right? But there's actually an opposite thought around this. Like, this basically means that there's a lot of things that's getting fixed. CVs are announced vulnerabilities that has been patched. And these are the ones that, like, this is happening a lot. There's a lot of things that we're currently fixing, constantly fixing. And when you look at a vendor, for example, and there's no CVs, like, that could potentially be a warning sign that they don't have a process in place. This means that there's a process in place to actually handle vulnerabilities.
And this goes back to some of the communication. If you're honest about what's going on inside your applications and your enterprise, and you can say, look, these are our CVEs for the last year, and yeah, we had a big problem. We had a development cycle that we screwed some stuff up, and we fixed it, and now it's all closed. That's a big statement to your customers, and that's a big statement to the world at large. So from a certain point of view, as a hacker and a defender, I want to know that you guys are on top of it. I want to know that you're actually doing your job. I want to know at the end of the day, my information, because frankly, I am also a customer of some of these people. I want to make sure that my information is going to be safe. And this is one of the best ways to know. Yeah, you guys had some problems, and yeah, you fixed them.
And it also, but it puts a pressure on the customers using the application, because the problem is if you don't have an update cycle in place, you will have a hard time because these are announced vulnerabilities. And there's a whole market around reverse engineering CVs, looking at how the patches.
We're getting ahead of ourselves.
Yeah,
we're getting ahead. Sorry.
No, it's true. It's true.
All right. So threat modeling. We've talked about our CVEs. We've talked about some other things, right? Now let's kind of roll it all together into one thing. So if we're looking at our applications, we're looking at segmentation, we're looking at the data that leaks between applications, and we understand what our assets in our company are and our assets could be combined with other data, then we can go ahead and look at the threat model that we have in front of us, right? Threat modeling is one of the things that we actually have to be really, really good at as we begin to do some of this defense. Because if I don't know what he's going to attack, then I'm going to lose, right? Anybody know, and I get that you guys can't hear each other, I promise to repeat your answer as long as you're in the front row. Does anybody know how we do this. We're going to get into it a little bit later, but I want to see if anybody knows the word. Simulated SIRS, simulated incident response scenario, all right? And one of the things that we can do is get into the concept of, I'm going to hire Frans, or better yet, I'm going to build an internal team to pretend they're Frans, and they're going to attack my stuff. And then we're going to get into actually, what is our threat model really look like? Was I right, was I wrong? This goes into a little bit of, and we're just going to touch on this briefly, I'm sorry, but we realized as we were doing the talk that maybe we should touch on it. We have attack surfaces, right? Now, I don't like the word attack surfaces. I know it's an industry standard word, but I feel like it's kind of angry, I suppose. The reality is you have three domains that you have to deal with. You have services, infrastructure, and application. Most of the people that I see on a day-to-day basis end up falling down around the services side, right? They forget to protect that. And then Frans goes in and looks at their S3 buckets and everything ends, right?
There are exceptions to this as well.
Oh, yeah.
Like,
always.
I was attacking a service, and this service was patched. In production, everything was working. I put in a bunch of test payloads, and everything, like nothing was triggering at all. And then a couple of weeks later, I get a trigger. And this trigger is not from their production. It's from a developing machine in the office. So the whole production system was patched. Everything was good. The problem was that one developer was downloading a live backup, run that live backup, and one of my payloads triggered because of that. So suddenly now I have a shell on the developing machine, which is like, it's outside of the like, we have dev, we have staging, we have like, but you also have like someone downloading a live backup, running it locally.
So who's an auditor? Anybody here an auditor? Anybody here a security individual that worries about their audit boundaries? What happens when I, as a developer, download your production database to my laptop? Where does that audit boundary go to now? Uh-oh. That's not a good answer, right? So we're going to get into a little bit about the segmentation, right? We're dealing with privacy by design here. We have to figure out where our data should be, where are those lines, and how do we defend this? How do we defend the services that developers have access to? That brings us to threats and change. Yay!
Yay. And there's not like much that have changed. Like if you look at the reasoning why people are doing hacking, you could look at like the economical incentives has always been there. The only difference now is like it's much easier. Before you had groups in specific countries that was like they were really good at scamming people on credit cards, but now you can do it as a youngster in whatever city you want. So there's a lot of simplification and convenience also in being anonymized that actually helps these things to increase. And the funny thing was, I was talking with a guy from an old hacking group, and this guy, I started talking with him. He got caught, he got in jail, he got out, and this was a couple of years ago. And I started talking with him, like, what do you think? And he told me, like, I'm really into bug bounties now. And I'm like, okay, that's super interesting. Like, how do you see the difference before, like, now and then? He was like, I would have never done the hacktivism thing at all if bug bounties was a thing. And when you see this, you start to realize that like there is a convenience and laziness kind of thing that you should also take into consideration. It's much easier to know that you're going to sleep at night, that your family is going to be okay, but you can still do this hacking. And that's a really, really interesting thing that is happening right now, that the convenience is happening all over the place. It's happening on the bad side, it's also happening on the good side.
I think that's a really important point. Who's concerned about social awareness? I mean, we all should be a little bit, right? But when we look at something like this, there is certainly a question that goes through my mind as a security person. How many people in the world are actually doing this because they need a job and they actually just have something that they need to make money doing? And it's an interesting question because all of a sudden, if we start looking at red teams, if we start looking at bug bounty programs, it actually gives us a way to start activating some of those people that were going to do negative things. And now we can activate them for a positive end as opposed to a negative one.
Yeah.
So this is what we love to see in the sales demos, right? The world's a crazy thing. And I saw a guy go, what? When he saw this, right? So it's hard to read a little bit, but encounter percentages for Windows systems over 2013 to 2017. At this point, this is 06. Whoops, there's a typo.
06 and,
yeah this is 2006 to, yeah, okay. But this is how the world was in 2006, right? We had all sorts of things, Trojans, exploits, spyware happening all over the place, right? And it was insane. And I remember staying up at night and helping different companies fix themselves. And the world was scary. And all of the salespeople would show us wonderful graphs like this. We would go, oh goodness, we're screwed, right? However, we get to now.
Yeah, 13 to 17.
Yeah, this is 13 to 17 now. And we see all of the craziness dwindle. What's the big blue line? Anybody want to guess?
Yeah, who's the reason behind the blue line?
Yeah, it's Trojans. It's the thing that requires you to get in and screw up. So who's the target now? Is it your computer, or am I looking at the target? The reality is it's infinitely easier for me as the hacker, or Frans as the hacker, to social engineer the lot of you. Right? Everybody stand up. Come on, stand up. How hard was it to get a room full of people to stand up?
Worked. Yeah.
So the intent is that a lot of malware these days isn't something that necessarily is something that your tools won't find. You guys all have the tools already to do this. The issue isn't that the tools are bad or not doing their job. The issue is that we're not doing our job.
There was a big happening in Sweden a couple of years ago, and there was a group of hackers that was approaching companies. And the idea was they went for the economy team. And what they did was, with a legit email from a legit company, they sent them an Excel file saying, we're getting some invoices from you guys, but we are not your customer. Like, why are we getting these invoices? And the economy team said, but we can't open Excel files. We're not allowed to open Excel files. And they responded back and saying, okay, here's a PDF instead. But the PDF was white. And they also sent the Excel file next to it. So the economy team was like, oh, should I try again? So they opened the Excel file. And they got in, they started, they were there for a couple of months and realized exactly how the economy team worked. So they could actually put some orders in for their vendors and then steal a bunch of iPads, for example.
That never happened, did it?
It did happen. I'm sorry, but it did happen.
So that kind of brings us to an interesting question then. What are our threats? Is the threat the guy in the hoodie that like stalks around the edge of the building? Okay, yeah, sure, maybe. But I argue that this guy is your threat, right? I argue that it really tends to be an issue of generally open boundaries, like you had said when we were talking.
Yeah.
My developers have access to production. My developers have access to the database because they need it. They really have to get access to that production data. When we end up, the very last item here is oddly the office of no. Do you want to talk about that a little bit?
Absolutely. I mean, the problem is when your security team is so divided from your developing team that what happens is that people will try to go around your security team and try to avoid them to not get the no in their face. And I mean, there's some companies really trying, and we're going to get to that later, that is really trying to change this by like alcohol or candy.
Or candy, frankly, even candy, yes.
Like not just that. But the whole thing about like avoiding the security team has been a really, really big problem when it comes to like your developing team and your SEC team is there to be like your last part of your defense.
Yeah. We'll get into that in a minute. We want you to remember that office of no, though. That comes back in a little bit.
Yeah.
So awareness.
And one of the examples when it comes to like internal threats or like basically convenience above security was also an example. I was actually looking at the security for a password manager. I won't mention any names. The password manager I saw was basically, I started looking at the code, the desktop app. And in the app, I could basically see that there were credentials and an email pattern in the code. And in this code, basically, it was three things. One thing was it had QA, test, star, whatever you wanted. And then it had a word called Azerty13. And then a bit down, it was something called a token.html. And when I started looking at this, I realized that if you would sign into this password manager with an email beginning with QA test, and provided this hard-coded password, it would send you to a URL called token.html on this website, and this one contained all the QA users' 2FA codes for the application. Very, very convenient if you're running QA that doesn't want to insert a bunch of credit cards to the app. They don't want to like register new users. They could just use whatever QA and then start testing. Super convenient. The problem was I could also see in this 2FA website, I could also see the real QA users that was testing things. And when I go in there, I also see that their internal Jira is also tested because it's a password manager. So I click on this and I get in, and suddenly I'm in their Jira. And I could potentially go in there and say, add a ticket, you should probably change your QA process. I did not do that, but that's basically the issue here. Like, it was so convenient for the QA that they were even testing their whole internal suite of applications.
This isn't the first time we've seen this. Actually, from an incident response point of view at AWS, I've seen a couple of customers do this, where they actually have special portals where you can recover your password internally. But you put star in there and it just lists out all the passwords for all the users. And it's one of those things where it happens, and it really is down this path of it was the easy choice. The developer was banging away at the keyboard, and all of a sudden, he made a mistake.
Yeah. And when we talk about the internal threats, you could also see that like one of the biggest issues nowadays is credential leakage. We have public source code repository websites. There's a bunch of them. And you could basically see like AWS credentials was a big problem in the beginning.
Yeah.
If you actually leaked your AWS credentials, you had like 4 minutes until someone was actually attacking those credentials. And AWS fixed this. Like, they are monitoring together with this website. Okay, not all of it.
We didn't fix it.
Okay. No, but like there is something in place at least that is looking for these things. But then you start thinking like, okay, that's AWS keys. They have a fixed pattern. They look exactly the same. They begin with the same prefix. But then you're starting thinking like, imagine how many things that is just custom, very specific, very obscure, unless you have the context of what those credentials actually mean. And I have a really like worst case scenario. It was an application. It was a company that had a bunch of applications, but one of the things that they had was a developer that was doing a backup. And he did a backup of his coding tools that he was using. And one of the tools that he was using was, just because convenience, he had a tool that signed in as an admin on their Salesforce account. And this was like without 2FA or anything, because it was an app that was running like a cron job, exporting reports to send them to certain people in the organization, because he didn't want to have a calendar reminder every day to go inside and export these ones. So he just wrote a simple code that would do this. And the problem was that he did a backup of his laptop. He put it out and forgot that it was public. So for 20 days, he basically had a repository with the admin credentials for this organization. And they kind of realized like, okay, we have no idea how to fix this like all over the place. Like, we can look for credentials, specific tokens. There's examples of like Slack had the same thing in the beginning. I did a blog post around Slack bot tokens, which is basically tokens that you can interact with to make certain bots in Slack. So you could interact, you can make it trigger a bunch of things. And what I realized back in, I think it was 2015 or 16, I realized that a bunch of people that was issuing these tokens didn't realize what they were for and what you could actually do with them. It turns out that those tokens...
You could copy and paste them.
Yeah, exactly. You can copy and paste them. But they were actually a combination of user, password, and 2FA. And that token just made you give access to everything. And you could just say, I want to see your DMs, and here's your DMs. And what happened here is that Slack adopted the same thing as AWS did, actually looking for these kind of credentials, which is like a good thing in the end. But imagine how many credentials, internal tokens, that nobody else will care about, that potentially can just get out there.
That kind of brings us to external threats. Fun, we all have seen the picture with the hoodie. Who's scared of the dude with the hoodie? Like, this is in all of the scary literature you could possibly get, right? But the reality is that I don't think it's the dude in the hoodie anymore, right? Because the reality is you don't wear a hoodie.
No, that's true. That's true. Sometimes.
But as we get into this, we start looking at the way things work, and it doesn't seem like it's criminals that are the types of criminals that we all want to think about anymore, right? Since when is a criminal interested in your Salesforce account? Why is a criminal interested in understanding who you sell to and who you get from? That doesn't make sense. Well, it doesn't make sense because you're not thinking about it from a business point of view. The criminals that we have to deal with today are in business. They are in business of making money. Their goal is making money. Consequently, this is probably more accurate than the dude in the hoodie. We are a bunch of people that like to make money. Consequently, we focus on how to do that. We set up organizations to make money. In some cases, some of these organizations actually have days off in HR, believe it or not.
And customer service.
And customer service, actually, yeah. We actually heard a really good story about a customer service system that they wanted to be rated after the individual had turned in their ransomware token. They asked for a rating on their ransomware token transfer. How screwed up is that? So stop thinking about it from the point of view of the hoodie. Start thinking about it from the point of view of an individual that just wants to make money. If I was going to want to make money from you, what would I do to make that money? What could I get from you to turn that into cash?
And one of the examples also, we did a malware analysis from a malware on Facebook a couple of years ago together with Kaspersky. And we kind of realized that what they've built was basically a way to gather these access tokens to access Facebook accounts. That was the whole idea of like doing this malware. But the whole structure of how they built it was 100% cloud services. They used like Google APIs for docs. They used Heroku for like services that was running. They were like, all the services that they used was cloud-based. And they were like silently doing this. This could have been like a startup of collecting like CRM data. The only difference was that it was actually just gathering Facebook tokens and then selling them to other people.
Yeah. It's an interesting side note here, and we're actually running out of time, so I think I'm going to skip the side note. But going forward, what does this look like? We're about halfway through the talk, and we haven't really talked about money, and I promised you economics, right? So what is the future? What is the cost of incidents? What are we looking at? Did you guys know that you can Google that? So as an amusing side note, it's $148 a record. Does that seem right to anybody? Who's had an incident this year? Do you guys feel comfortable raising your hands? A couple of really small raises. Yeah. Right? Does $148 seem like the right amount of money to you? Okay, so I went in and kind of freaked out about this. As an incident responder, what does that mean? And this is the actual answer for what this is. Activity-based costing. Okay, I am not in any way, shape, or form a CPA, but this is totally, honestly, a really good way to judge this. We look at $148 and we're going to talk about direct cost. How much did it actually take to get this system fixed? So we're going to talk about outlay to the people that have to notify. We're going to talk about all of that stuff. Great. We're going to talk about indirect cost, the amount of time it took us to get everything set up. We're going to talk about all of the things that we couldn't do because, or had to do because of this thing. We're going to talk about opportunity cost. All of our developers for the last 3 weeks had to focus on this incident. How many people have been through an incident before, ever in their life? So now it's not just, okay. Did that take 3 weeks to you? Who took 3 weeks for one incident? Anybody? Yeah, not likely. So when we look at this, what was the actual impact? So having done this a number of times with a number of customers and seen what they actually go through, I think the $148 a record is silly, because we get into this concept of, well, what actually happens? Having gone through one recently, the actual impact was 6 months of development effort. They took all of the developers off of all of the future things that they were going to write, and they sat down and had to rework all of that for 6 months, because they then had to do tech debt. Who knows about the word tech debt? Tech debt is the thing that happens when your business decides it needs something now and they don't care, right? We've all been in this situation. The CEO comes into your office. I need this now. Okay, sure. And then 6 months later, we're still paying for that. So my argument is that while we have $148 a record and we can do an ABC costing on how we got to that point, the reality is it's millions and millions and millions of dollars more. So I want you to keep in mind this thought, all right? And we're going to keep this thought in mind because going forward, the way we're going to get away from these incidents, the way we're going to start thwarting them, is to use this as our costing that we're going to talk to our CFO about. When we talk about how we're going to defend ourselves, it's not $148 a record, right? I actually had a CISO, I had a chief counsel rather, point out to me that I was far more expensive than the $148 a record at one point in my life, right? He would rather pay the $148 a record than have to pay for 20 people on a security team. Okay, that's awkward. But when we get to this, I want you to think about it from this point of view. It's not the $148 a record. It's the 6 months of time that you've got. It's the opportunity that we lost as a development department. It's the momentum we lost as a development department.
And trust from customers with indirect costs. Like someone charges a credit card with $4,000 that would never be correlated with the leak.
Yeah.
But like
months later.
Yeah, absolutely.
So we look at other like major hacks that have happened this year or last year or the year before, and some of those people's stock prices actually went up because they rode the hack correctly, right? We look at how that happens. But long term, if you're a software company, if you're in this business, I would argue that this is more true. So how do we correct it?
From the beginning.
From the beginning, back to the basics.
Yeah.
Who's ever watched a sports movie? Like, you watch a sports movie and you go back to this concept of, we're going to go back to the basics. I'm going to argue that's actually true. Part of defense is going back to the basics. And being back to the basics means we're not going to just deal with our security team. Our security team isn't the last line of defense. Who here is a security person? Do you like that your entire company rests on you? Is that cool? Is it true? Because whose stuff do you fix all the time? Is it true that you fix your own messes? Whose messes do you fix?
Someone else's.
Yeah, you fix the developers' messes, right? You fix all the other people that made a mistake. And that's cool, except for the fact that you don't really have much of a say in it. So, if we look at $148 a record, and someone says, is this an example of a secure environment? What do you say? Anybody want to shout out and answer? Is this a security environment?
Maybe. That's a good answer.
How about this one? I have no idea. As a security individual, if I'm handed a VisioDoc, I have no idea if this is a security environment, a secure environment. As an individual for AWS that goes out and talks to customers every day, when everyone hands me, one of my customers hand me this VisioDoc and says, how did we do? Yeah, that's like the first 5 seconds of the day. Like we've got another 8 hours to talk about things. This is the beginning of the iceberg. We need to start talking about your people and process. And what that ends up in is DEFSEC Ops, okay? Who's happy to hear the word DEFSEC Ops? No one's happy to hear the word DEFSEC Ops. Why? Because it's hard to do, and it's expensive, right? That's the pushback that I always get. It's expensive. So I'm going to posit to you that DEFSEC Ops is not something that you magically turn on and you're not all going to get there Monday, but rather you're going to start a journey towards DEFSEC Ops. You're going to start looking at your applications as designing for security. You're going to look at developing privacy by design long term. You're going to integrate things together. And when your CFO comes to you and says, how are we going to pay for this? You're going to look at the incident response calculation of $148 a row, and you're going to say, well, that's not actually true. If we have an incident and we stop production for 6 months to fix the tech debt that caused that, it's actually going to cost us this much money. And realistically, when you look at all of that, if I can avoid it by doing DEFSEC Ops to begin with, this is actually much, much cheaper. This is not DEFSEC Ops, right? Is this DEFSEC Ops? Do you think this is DEFSEC Ops? I don't think this is DEFSEC Ops.
No.
Not so much. This is DEFSEC Ops. We are one unit pushing together as a business. It can't be a bunch of people trying to pull the business in different directions. This doesn't work. This is what we always see when people start. This ends up being a siloed mess. When we all work together and actually integrate, this is when we actually get things done. This is not an easy thing to do, but it's something that we can all start very, very easily and begin to move towards it as a goal. Let me be really honest with you. Very few of you will ever reach complete integration with DEFSEC Ops. You will never reach what they call singularity. It won't happen. And that's okay. You've still made a huge progression towards it and probably removed humans from production, which is really all I care about. Well, actually, we care about. Tactic 1, RCA. Does anybody feel awkward that I'm talking about RCAs as a tactic for defense? Do you know how many people I have to go to every week, every month, that don't actually do this process? We come in, we deal with an incident. I'm going to argue that one of the things that we forget to do is RCAs. And the RCAs don't have simple, followable action items at the end of the RCA. Oh, we didn't talk about what RCA means.
Root cause analysis.
Yay! This is something out of the 1970s. I mean, this is old stuff. But that said, it's still entirely valuable and it's still actually helpful. Why? Because at the very end of this, we get to a very small number of things that we can actually act on. And because we can act on it, we can play pretend.
We can try it again.
And again.
And simulate it.
And again.
Yeah. And try it on new people and new employees coming in. Try old things. And as you said before, like, we can actually replay this much, much longer after the incident has happened to make sure that all people are on board exactly what was done and how we could actually change it forward.
So think about bringing a developer on new that's never used your product before, never written in your product before ever, and they actually sit down and do a simulated incident, right? And they look at something that actually happened to your company 6 months ago. How does that change the way they develop? Does that give them the knowledge that they actually need? My argument is yes. Defense tactic 2. Let's compete. We all like sports, right? We all like score. Who doesn't like to know they're the best? You like to know you're the best. Right? The reality is that we can compete with simulated incident response. We can actually say, was my team able to get to your target before your team was able to get to my target? We talk about this in terms of typically a team doing their own thing. And that's great. I'm going to posit that it's even better to have multiple teams in one of your companies fire at each other and fire at different apps as opposed to fire at their own. Why? Because they learn how to be devious. They learn how to think like a hacker. They learn how to think like Frans.
And do we want devious employees?
Yes.
Yes.
Yes, we do. Because devious employees think like Frans does. That's a good thing. We want to be able to defend ourselves, and that's the only way to do it, right? I'm going to also promote that you actually compete with other companies.
Competitors.
Competitors, potentially. How awkward is that? Wouldn't it be pretty cool if a bunch of banks got together and said, you know what? We're going to let you shoot at our simulated app over here, and you can shoot it, we'll shoot at your simulated app over here, and we'll talk about the results. And we'll be honest with each other and tell each other what's going on. Is it good for business? Yes. Is it going to make better apps? Yes, absolutely. And will your people know better how to defend their own stuff when they're done? One of the things that we have to do here is rules of engagement. Do we use this against production applications? Shake your heads, yes or no? That's right, no. We don't do this against production. This is a bad thing to do against production. But that said, if we set up some significantly straightforward rules, like we're going to set up an architecture and you're going to set up an architecture, suddenly then we've actually begun to embrace DEFSEC Ops because we have to set up a whole architecture for this other team to attack easily, right? We can't spend a lot of money on this. We're able to get to the point where we're actually using data that is useful to us. Don't use production data. We just talked about spreading out your audit boundary. This is not something that you want in your audit boundary. We want target data. I'm going to suggest that we engage red teams and teams like you. I think that's good.
Absolutely. I mean, the interesting part here, if you engage all the people and you find ways to get people interested in security, like one of the really hard things when your developing team, for example, gets to like meet someone outside of your company, coming and talking about how certain security vulnerabilities work, for example. There's a lot of developers that could not get it into their context and understand the context that they're working. Like the person speaking will say, but you, like, we're talking about a banking app. Yeah, but we're not building a banking app. We're building a grilling app. So the context will always like differ from the person talking about those issues. But as soon as you put the context of those developers and they get to, as you said, like they get to build their own testing environment that kind of simulates what they're doing in their production, that makes them understand like really why they should care about this in the context of what they're actually building.
Yep. And we're a little late, sorry.
Yeah, so don't do this. This is an example. I submitted a report to a company. This was publicly available yesterday. And in the report, the security team is like, I will visit that team now because of this bug. And he did it, this is humor, right? He will not hit them with the baseball bat of goodness. It's just that there's a mentality here that might not be 100% okay if you like to be, like this is kind of aligning with the officer no thing in a kind of hostile way. But this is just like, this is not the way you should do it. I've heard better examples of where people have, like, whenever an incident happens, what they do is like they grab a bag full of candy and they go to the developing team and say, here we go, let's sit down and talk. I mentioned alcohol before, but seriously, there's some San Francisco-based companies that have a whiskey bar next to the security team. For real, like more than one. And the whole idea there is that people go to that whiskey bar after they've been working and like, yeah, I'm building this thing. What do you think? And the security team is like, okay, maybe you should think in a different way here. Maybe you should not have the social security number in your grilling app. Maybe we don't need that. And they're like, okay, that's pretty cool. Let's find a better way of buying burgers.
QR codes are really just that simple. If your security team is the last line of defense, your developers are your first line of defense. So if you end up looking at things from the point of view that the security team is the office of no, you lose your whole first line of defense. You can no longer trust your developers to defend you. And if you can't trust your developers to defend you, the only people you have left is the security department that now no longer knows what the developers are doing.
And some worst case scenarios of this has been, I talk with the security team of a company, and I talk with them like, how do you work with developers? How do you engage them? And he's like, engage? I'm like, okay, what happens when someone submits a bug to you, for example? And he's like, yeah, we then send a report to that dev team in a different country, and we say, this vulnerability, please fix this. And the developer team comes back a few days after and saying, this is fixed now. And then the security team comes back and say, you fixed field number 1. Can you fix field number 2 as well with the same kind of problem? And then same thing happens, and then they go field number 3, please. And then it's just like iterating there. So he was like totally depressed on like, this is not how we should do it. This is not fixing the root cause. We're just the ones saying, please do this thing, and they will do that thing. They won't think about it in a more holistic perspective.
So how does AWS do it? So we don't actually, I mean, we have security teams, but everybody is expected to be a security member. So all of our developers, all of the employees we have, whether you're an HR consultant or you're an individual that happens to be in the mailroom, security is your thing. Security is job zero. It's what everybody does. One of the things we talk about is SEP312 tickets. Does anybody know what a SEP312 ticket is? No? A little bit? So SEP312 means that my boss's boss's boss, or something along those lines, who is right under Mr. Jassy, is going to get an email. Is that a big deal? Yes. Does anybody care? No. It's an interesting thing, but we actually go ahead and have SEP312s when we need a SEP312. And the vast majority of them we don't need. We actually hit all of the SEP312s we're supposed to, and yes, there's a significant amount of extra, and the security team is really good about going ahead and getting rid of it. Is the security team mean to the individual that went ahead and posted the SEP312? No. It's not. Occasionally we do get some giggles. We do have a site that talks about people that enter SEP312s accidentally. There are sandwich orders that make it to SEP312 accidentally. Sandwich orders should not be on SEP312s, but it does happen. Should the security team berate the individual that made a SEP312 for that? No. We laugh about it, we make fun of it, we go to the whiskey bar, and we have a good time. Bug bounties and internal gamification.
Yeah, I mean, when we, like, as I said, like I come from the bug bounty thing, I should be like 100% for this. And there's a lot of good things with bug bounties. And when I think about bug bounties and like the extension of this is that I see like there's an internal gamification to this as well. And I've seen some companies do this. They embrace trying to get people internally to submit bugs, and they have perks, they have different things to actually help them. They also use it like in the review process of negotiating your salary. They use it as a form of like showing that we care about security. We are not your security team. We're actually developers that care about this product. And I should probably say like, yay, bug bounties will solve everything. Just fire your security team, go for bug bounties. But that's not how it works. Like, I would say that bug bounties is really good if you have processes in place. If you're doing pen testing, it is not a replacement to anything. And I'm saying that, like, I crossed $1 million on HackerOne, one of 4 people doing that, and I should be, like, all pro it. But that's not the truth. Like, the best teams I've been working with are the ones having proper processes in place to know exactly how to fix the bug, and to fix the bug once and never, ever have that bug again. Like, there's a bunch of companies that said, like, if this bug happens once, we will write regression testing for it, automate and make sure that this never shows up anymore. Because what happens if you don't is that you will probably pay for that bug multiple times. You will probably pay because there's a pen testing team spending a bunch of time trying to write a proof of concept for it. or internal people trying to make sure that like they're trying to patch it in a different way a second time because of regression. There's so many things that could go wrong if you don't have those processes, and bug bounties is just the end result of like, if everything came out of your security team, of your developing process, through the pen testing team, through automation, and still got public, like you have something as arguments to go back to all those levels of people saying, there's something wrong here. Why did we not have a process in place to find this? This was publicly exposed and someone outside of our company found this thing. So it's just a very, very good thing to like eliminate regression, make sure that stuff don't go back to go out in production, and also make sure that you put pressure on people in the upper levels of your company.
All right. So closing thoughts. We've got 9 minutes left. We're going to go try to quick here. People are more security aware than ever. I would argue that the people in front of me have done this, thought about this, been involved in this far more than they've been involved in things like this 20 years ago. We all agree on that? That's pretty straightforward, right? You're aware that you shouldn't give your social security number to somebody, and that things like finger and gopher as internet protocols are generally a bad thing. Probably don't remember those. I might have just given away my age. Okay, fair enough. The reality is, however, that things like whaling still work. I can still sprinkle USBs in a parking lot. The issue, if we look at the actual graphs and stats, the things that I see on a day-to-day basis, when I see attackers hit a website, they're not going in through the front door anymore. They're not going in through the firewall. They're not going in through stuff like that. They're attacking your architecture at the weak point. All of you. Me. Frans.
Yeah.
Right? They're attacking us through things that we should have known about and we frankly have the ability to take care of. The reality is that I still can't update your firmware. People get awfully awkward when you start approaching them with that USB and like trying to poke it at them. They're not happy about that. But the reality is the issues aren't with our products. We have lots of tools. We have lots of really good tools. None of those tools stop an individual from picking a USB up in the parking lot and continuing to try to plug it in until he gets it or she gets it to work, right? The cool thing is that while we are the problem, we're also the answer.
Absolutely.
We have the ability to put together processes and procedures that help us protect each other, so that one individual can't be able to interject themselves into production. Production can be protected by the process and procedures that we set up. Even if you can't get to DEFSEC Ops, you can get to a point where humans aren't in production, or there isn't a single human in production.
And also, gamification. I mean, a really good thing to get everybody on board is to actually engage them in a way that makes it exciting and get them interested into how to think about security, how to realize when stuff feels bad, and when like convenience trumps security is a really, really very, very like dangerous path to go. And if you can get people internally to realize that convenience was probably trumping the security part of this, and you can identify those things, then you're on a really good way of like realizing or growing your security knowledge internally.
Yeah. So I would argue the best way to keep yourself safe in the future is integrate your security department. Your security department shouldn't be a bunch of people that sit in the basement and smell funny and you make jokes about. The security department should actually be part of the development team. You guys should actually be completely together. There's no more Office of No. There is only the Office of Us. That's it.
Thank you.
We would call you guys to action. We just kind of did. If you would go ahead and hit us up on LinkedIn and Twitter, we'd love to go ahead and connect with you and continue to communicate with you. Anything else?
No, that's it. Thank you very much.
Fill out your surveys.
Thank you.